All right, hey there, chem students. Time for our next installment of how to write names and formulas for things. In the last lesson, we looked at binary ionic compounds and how to deal with those things, metal, non-metal compounds. Today we're going to look at a different group of them. This is the binary molecular compounds. These are formed from nonmetals only. So this is one of those groups that we don't worry about a lot in Chem 1. We do visit them a lot, but don't spend a bunch of your time freaking out about this one. The other video is actually quite a bit more important, that lesson about the ionic compounds. This one less so. It's actually pretty quick, pretty easy, but I worry that you're going to spend too much time on it. So anyway, where do we start? First thing first, definition-wise, we have to ask ourselves that series of questions, and you need to go through this as you get to more, kind of bigger lists of things that you're trying to write names and formulas for. First question you should always ask yourself is how many elements are present. So do we have 2 elements present or more than 2? And then you need to start looking more closely at what kinds of elements are present. So in the last lesson we took a look at the case where an active metal and a nonmetal was present. We called those type 1 compounds, ionic. And then is there a transition metal and a nonmetal present? We call those type 2 ionic. This particular lesson is going to focus on the case where there's only nonmetals present. So 2 or more in the case that we're doing right here, 2 nonmetals that are present. So if you take a look at the ones that are on the screen, hit pause or whatever you need to do, but look through that set, and can you identify which types of molecules we're going to be dealing with in today's lesson? So the ones that are going to go away, copper 2 sulfide, that's a type 2. Fe2O3 is a type 2 as well. MgNO3 isn't even binary, but that would be a type 1, I guess, sort of. And then calcium oxide is a binary. So those 3 that are left on the screen right there is our non-metal compounds. So again, these are the elements found in the top right corner of the periodic table. So this one is about binary compounds, so we're only going to be dealing with elements with 2. And then this is a different style of compound. These are molecular compounds. Up until now, we've been talking about ionic compounds, and most of the time we're going to talk about ionic compounds in Chem 1. A covalent bond is formed inside a molecule. Molecules are different than ionic compounds. In ionic compounds, remember, electrons are gained or lost, and they're held together by that fact that positives and negatives attract. Well, in this kind of a compound, these are where they're sharing some electrons. We're not going to get into the details of how that bonding works right now. We'll get to that later on in our year. But for right here, we're just going to talk about the fact that it's a different bond style called covalent bonds. And these things, because they're sharing electrons, form these very stable groups that we call molecules. And in this case, we're only going to deal with molecules that are being formed from 2 nonmetals. So in terms of writing their formulas, some slight different rules have to be used here because we've got 2 nonmetals that are forming. So because they're not ions, if we looked at their ionic charges, they'd all be negative, and they shouldn't really bond together in an ionic form, and they don't. So we can't just use the charges from the periodic table to figure out how these guys work together. The rules are actually kind of complex. So luckily for us, we use a really cool shortcut. The name itself is going to actually tell you what the formula is, and it's really, really nice once you get the hang of this. We use these things called numeric prefixes, and you're actually familiar with this whether you know it or not. I've got 2 examples on here, carbon dioxide and carbon monoxide. Now these are both molecular compounds because they're 2 nonmetals. Carbon is a nonmetal and so is oxygen. So we would think maybe they wouldn't bond. And here's 2 different forms of it. So you can tell from the names that carbon dioxide actually tells you the formula. 1 carbon, and di means 2, so 2 oxygens bonded together, as opposed to carbon monoxide. Mono means 1, and so that's the other form of this particular compound with a carbon and a single oxygen. So like I said, these type 3 compounds are really nice because the names tell you the formula. They tell you how they're put together. So look at some more examples here. So one of the things that students really like is because it is really easy. It makes all the other stuff we do look so much harder, so it's kind of frustrating there. But when you're writing these out, it's kind of nice. Just write them in order, just like the name says. You do need to know the numeric prefixes. There's really only a couple that are kind of strange. So if you look at that table in green, you probably recognize a lot of those from math class. Like we have triangles, and we have pentagons and hexagons and octagons. The couple that are a little bit different for students is tetra means 4. And then hepta means 7. Those are the 2 that students really have a hard time pulling out. We don't see nona and deca a whole bunch, but they do show up occasionally. The other one's a little bit weird, di instead of bi, so I know it's a bicycle, but it's actually a diatomic ion. ion or something like that. And then the last one that you need to watch out is the term mono. Just like in the carbon monoxide example on the previous slide, we only use mono on the second element. We would never use mono on the first element. I'm not sure why they decided to do it that way, but that's just sort of what everybody agreed on. So here's two examples for you. See if you can write formulas for these two type 3 molecular compounds. We've got carbon tetrafluoride and dinitrogen pentoxide. So take a second and work it out how that works. I'm going to hit pause, kind of mentally. All right, here we go. So carbon tetrafluoride, well, you'd write the letter C for carbon, and the second part of that, tetrafluoride, means there's fluorine present, so you'd write an F, and the tetra stands for 4. So we just write CF4. It's actually that easy. Dinitrogen pentoxide, sounds really complex. It's not. There's nitrogen that's there. Di means 2. There's oxygen that's there. That's the second word. And penta means 5. So dinitrogen pentoxide is 2 N's and 5 O's. There you go. Pretty straightforward. I really like these. Okay, so in terms of dealing with these, writing the names going the other direction is also pretty straightforward. Once you've got a formula in front of you, then you just kind of use the prefixes to name the formula. Again, it really is that easy, except for remembering not to use mono on the first compound, or the first element present in a compound. So here's a couple examples for you. If you wanted to write names for these things, we've got P4S9, and then we have IF7. So how would you write the names for those? Got an idea? P4, all right, so that's phosphorus, and then we've got 4 of them, so that's tetra. So we would say tetraphosphorus. Sounds really weird. Then we've got sulfur over here with 9 of them, so it's sulfide. We have to put the nona in front of it for nona sulfide. So wow, putting it all together, tetraphosphorus nona sulfide. I know they sound really, really weird when you get these big compounds. All right, shifting over. The one on the right, the IF7, so it's iodine. Again, we don't need to use mono on there because it's the first element, but yes, there's only one iodine there. And then the second element, we've got fluorine, and there's 7 of them, so we use the prefix hepta. Change the ending to IDE, and we get heptafluoride from that thing. So it's a mouthful. All together, we get iodine heptafluoride. So again, very systematic. Don't stress about these too much. Once you remember what those prefixes are, the trick not to use mono, the trick to change the ending to IDE, it's actually really simple, much easier than a lot of the other ones that we end up having to do. A couple of words of caution here. This system is so easy that a lot of times students want to use the system for everything, and you're not allowed to. You're only allowed to use this mono, di, tri stuff with non-metal molecular compounds, or type 3 molecular compounds. You're not allowed to use these with ionic compounds at all, and in fact it's one of the #1 mistakes that students make on formulas, that they start to try to put these compounds, or these prefixes, in ionic compounds, and they end up getting things wrong even though they kind of understand it. So be very careful with that. It also sounds really scary when you're making up names this way. So dihydrogen monoxide, it's frightening stuff, watch out for it. Scary, okay? So anyway, as you're doing these things, be very careful with this. Like I said, it's so easy. Students want to do it everywhere. You're not allowed to. Metal, non-metal compounds do not use this. They have to use Roman numerals and things like that. Non-metal compounds, these molecular ones like this, can use the prefixes. Okay, so what do we do today? In terms of kind of looking at this, we kind of reviewed what a type 3 is, kind of gave a definition. You have to have 2 non-metals present. The second thing is to kind of be aware that there's a different bond holding these together. These are covalently bonded, so they're a little bit more stable as a set. They don't really separate in water the same way that ions do. So again, just a different style of compound. There's molecular as opposed to ionic. We use these numeric prefixes, which are pretty straightforward, except for those couple little weird ones, tetra and hepta especially, to indicate the numbers of each element that's present in that formula. Change the ending to "ide," just like every other compound that we've been dealing with binary so far, so that's consistent. And then make sure that you don't let this habit bleed over to the other compounds. So that's the #1 thing I worry about when students learn this, that it's so easy they want to do it with everything. They want to call it like sodium monochloride or magnesium dichloride or something like that, and you can't do that. So just be aware of that, and then you'll be all good. All right, so we'll see you next. The next lesson is all about polyatomics. So if you haven't been memorizing your polyatomics, you better get started. See you next time.